Good morning all. I am Dr. Gayathri NS, working as Assistant Professor of Chemistry in SNS College of Engineering. We already seen in the previous video about top-down approach and bottom-up approach for nanomaterial synthesis. We directly move on to the one of the method CVD for preparing nanomaterials. CVD is nothing but chemical vapor deposition. The CVD involves dissociation or chemical reactions of gaseous reactants in an activated environment. The activated environment is like heat, light, plasma, etc., followed by a formation of stable solid product. The formation of soot to be due to incomplete oxidation of firewood, since many times is probably the oldest one is deposition using CVD. Patent literature by D. Lodigoin in 1893 for deposition of tungsten onto carbon lamp filament through the reduction of tungsten chloride by hydrogen, which leads to the industrial exploitation of CVD. Chemical vapor deposition is a process whereby the solid material is deposited from a vapor of chemical reaction occurring on or in the vicinity of normally heated substrate surface. Mainly the substrate should be a catalyst, that is zinc, lead, etc. The solid material is obtained as a coating, a powder, or a single crystal. By varying the experimental condition, substrate material, the substrate temperature, composition of the gas mixture, that is the reactant taken, and the total pressure, all may be vary. The CVD is an example for solid vapor reaction. These are the main component of CVD equipment. First, the carrier gas is allowed to pass through the evaporator chamber and to the next chamber. In that, a substrate is fixed in the center, and at bottom and top the oven setup is carried out. The reactor gas is in, and the other gases are pumped out in the outlet. The chemical vapor precursor supply system. The role of this component is to generate vapor precursor and then deliver to the reactor. The design of CVD depends on whether the starting material solid or liquid. It should changes about like a solid, liquid, or gas. The sublimation of a solid precursor depends on the surface area of the solid and contacting. The liquid sources often use as a bubbler to vaporize the reactant and the carrier gas, such as hydrogen, or inert gas like argon, to transport the vaporized reactor in the reactor. CVD, there are two reactors, cold wall reactor and hot wall reactor. In the hot wall, the substrate, that is water, and the walls of the reactor are heated. It is an homogeneous temperature is maintained inside the reaction chamber. It has also own disadvantage, like contamination is the main disadvantage. The cold wall reactor, the reactor uses heating system that minimize by heating up the reactor walls while the water is being heated up. The temperature is not homogeneous inside the reaction chamber. It is also having disadvantages that it is difficult to get a uniform layer of the film. That is the main disadvantages in the cold wall reactor. And these are the hot wall tube and cold wall chamber. The gas inletted wafer holder at both top and bottom is heated in the oven. We pump out the product, and this is the cold wall chamber. The main component of CVD equipment, the effluent gas handling system. This component consists of neutralizing part of the exact gases, that is outlet, or vacuum system to provide the required reduced pressure for the CVD, which process that performs at low pressure a high vacuum during deposition. The unreacted precursor and corrosive products such as HCl are neutralized or trapping using the liquid nitrogen trap. Inflammable gases such as hydrogen are burned off. Unreacted expensive precursors may be collected at the outlet and recycled. A typical CVD process, the substrate is exposed to one or more volatile precursor which react and decompose on the substrate surface to produce the desired product.